Just remember, I'm here today. Tomorrow will be virtual. So tomorrow is the day you guys have that half-hour break. No, tomorrow's the one day that they teach right up to class, right up to this one. Tomorrow, Tuesday is always for this class is always going to be over the net. Having me only in the building on Mondays and Wednesdays. This room will still be open. There'll still be somebody. They'll come and log in and put it on the screen for you. Okay. But I won't be in the room. Your class is literally the only of all of my classes on Tuesdays. Your group is the only one that's actually in the building. So they just told me they. Okay, so we've looked at the different forms of numbers. I'm going to take a little bit of a different course today, and we're going to talk about basic geometry. Well, with our arithmetic, we took the viewpoint of a couple of basic concepts, and everything is built from there. The same thing is true in geometry. The most basic principle in geometry, or the most basic structure in geometry, I should say, that right there is a point. It is simply a location. It has no width, no length, no height. It has what we call 0 dimensions. It cannot be measured in any direction. There's nothing to measure. There's no size there. But that point, as basic as it is what everything else in geometry is constructed from. Take that point.
Wait, hi.
Oops, can you see the screen, Sean?
Yeah, I can. I did get your test. I just haven't figured out how to send it to you guys.
So if you go into Blackboard.
Anyways, sorry. Sorry.
Click in course information. Go to where the quiz was posted. If you click on the title of the quiz there instead of the link to download it, then it'll take you to a spot where you can submit the quiz there.
Okay.
Click on browse and upload it back there.
All right, thank you.
Okay, so if we take that point and we pull it in a single direction, we create a line. Technically, it's a line segment. Because a true line would go on forever in both directions. But in reality, that's just not very practical. Pretty much everything has some sort of beginning. And generally it has an end. We can envision something that has a beginning and goes on forever, but we can't envision something that just never started. It was always there. It's been going forever. That's hard to realize. So in practice, when we say the word line, typically what we're talking about is a line segment. Now the length of that line segment is equal to the distance that the point moved. This now has one dimension. You can think of that one dimension in a few different ways, actually. First, it's one dimension because it's created by moving that point in one direction, a single direction. It's measurable in one direction. So you can actually get a measurement in one direction. That's one dimensional. Also, if I'm on this segment, I can only move in one direction. Now you might say, well, I can move right or I can move left, but that's still just one direction. It's the positive and negative of that direction. So it's one dimensional. That is how length is actually created, is by taking a point and moving at that distance to create that length. Now, if we have that line segment, that length, and we take it and we move it again. Now, to move it again, I have to define something called perpendicular. Perpendicular, fancy word meaning at a right angle. It means at a right angle in every possible measurable direction. Now, for this line segment, perpendicular, there's only one way that's perpendicular. That would be down or up, that right angle. That's perpendicular. So if I move that line segment in a direction that's perpendicular to the original orientation. So like this. Think of it as a stick being dragged across the sand. Gonna trace out. There we go. It's going to trace out a rectangle. That rectangle now has 2 dimensions. Again, you can think of it in a couple different ways. It was created by moving in 2 directions, so it has 2 dimensions. It can be measured in 2 ways. It can be measured horizontally or vertically. And if you're on it, you can either move right or left, or you can move up and down. So you can move in 2 different directions. Moving at an angle like that, by the way, is still only moving in 2 directions. There's a horizontal component and a vertical component to that movement. If you're on a flat surface, there's technically only 2 directions you can move, the positive and negatives, combinations of the 2 that you can move in. Well, the size of that rectangle depends on the length of the original segment, and once again, on the distance moved. That distance moved is commonly called a width. A rectangle, at least, is called a width. And that, of course, makes an area. The area, the size covered by that rectangle, is dependent on those 2 quantities, the length. And I'm going to write down width here, but we know that width is really a distance moved. So if I have a rectangle, and its length is 15 inches, and its width here is, let's go 6 inches. I'll put a right angle in the corner there so we know that it's a rectangle. Area, we found by doing what?
15 times
inches times 6 inches, yep. And yeah, we're going to multiply the counts. 15 times 6 is 90. And we also multiply the names. Inches times inches is squared, so 90 square inches. Now, the reason I said, rather than saying area is length times width, I mean, I did say for a rectangle, area is just length times width. But I mentioned area in general being a length times a distance. The reason for that, distance, by the way, we mentioned that term perpendicular. Distance is always measured perpendicular in orientation. I have a figure that looks like this. My stick again, and let's say that this is still 15 inches long, just like in our rectangle. But instead of pulling it like this, I'm going to pull it at an angle like this. Notice it is still staying in the same orientation it started. It's staying parallel to its original orientation. The difference is now now what it's traced is not a rectangle, it's what we call a parallelogram. This is 15 inches here, and let's say this is 7 inches here on that dimension. Is the area 15 inches times 7? No. The 15 and the 7 are not perpendicular. Used to calculate area, I have to use two dimensions that are perpendicular with each other. What I need to know is the distance, where the 15-inch piece started to where it ended down here. And if that distance is 6 inches, what's my area going to be? 6 inches, or still 90 square inches. So that's why I say it's distance that's moved is important rather than width. Because length times width only applies in a rectangle. In fact, the piece doesn't even have to move in a straight shot like that. Let's take that 15-inch piece, and we're going to, probably going to frustrate me again, but we'll give it a shot. And I'm going to take it, and I'm going to move it, and I'm going to wiggle like this. So, it kind of goes kind of back and forth like this as I went.
I'll do that too.
Well, think of this as like a stack of papers, or a stack of really thin rectangles. If I go back up here, this is just a stack of really thin rectangles here. Get down to that 6 inches, right? Well, down here, if this is still 6 inches, think of this as a stack of really thin rectangles, or the stack of papers, however you want to think of it. All I've done is taken that stack and kind of pushed it and skewed it a little bit. Does it end to have any more area or less area than it did before? Oh, it's the exact same area. The area here is still 15 inches times the distance moved. It moved 6 inches. It didn't go in a straight line, but it still moved 6 inches. As long as it stayed parallel to its original orientation, like it did, the area is still 90 inches squared. It doesn't change. Now, I'm not going to make you find weird areas like that, but it's the same concept. Actually, that's the concept of calculus, by the way. I'm not doing calculus in here either. Don't worry. But it's all really calculus is chopping stuff up into really small pieces that we know how to find the area of, and then finding the areas and adding them up. That's all calculus is. So anything, if we slice it into small enough rectangles or triangles, we can find this area. So if I have a rectangle, say it is 27 feet long, 3 feet wide. How do I find its area? 7 feet times 3 feet. Very good. And of course, we combine the counts. 27 times 3 is 1 feet times feet. I have to draw pictures. That's when you have to start using your imagination, because my art sucks. Very good reason why I'm a math teacher, not an art teacher. My handwriting sucks. I appreciate it. I actually had to work very hard on my handwriting. I started teaching so that people.
You're going to find this funny. I had an art teacher who would say the opposite.
Couldn't do math though?
Yeah, he's like, I can't do math, but I can do art.
I know some people just have, they're actually doing math and art, they just don't realize it. I had to take an art class to get through calculus. And I had an art professor that was very good about explaining the math that goes on. A lot of artists do it without really thinking about it. But like if you have a house in the background and a person standing, like that's way in the background, there's a person standing up close. Well, that person might appear to be taller than the house because of the perspective, because they're right here and the house is way back there. And how to create that perspective without making it look way out of whack, it's math. It's all about angles and your angles of view. And it's really weird. You can get very precise. I got through the art class because he basically had me doing math to make stuff like that fit.
Oh, favorite sequence in art and in math is the Fibonacci sequence.
That's very artistic. There's also like golden ratios and stuff like that.
Yeah, they're very similar. It's just like one is like close, like one's like slightly different.
Okay, so for this rectangle here, 7 inches by 24 inches, the area would be what? 168. You are correct. Good. Now, very closely related to that rectangle, this right triangle. Now, by right triangle, I mean it has a right angle in it.
Oh, I know this one.
A squared plus B squared equals C.
Strong one. I was going to say that.
You're actually ahead of us on that. We're not going to find the missing side. We're just going to find the area.
Oh, 7 times 24 divided.
Why is it divided by 2?
Because it's half of the square.
I have to say this is the funniest math class I've ever had.
You're welcome.
So we got
Thank
7
you.
inches times 24 inches divided by 2. And you said it exactly on the head. It's half of a rectangle. In fact, that's how it's defined. All areas are actually defined as being a rectangle. This is half of what we call the related rectangle. Related rectangle is the rectangle that triangle is cut out of. It is literally half of it. 7 times 24 was 168, divided by 2 is 84 square inches. It's half of this related rectangle up here. Now, not all triangles are right triangles. I have a triangle like this. Let me tell you that the bottom here is 16 feet. The related rectangle,
That one? Oh, never mind. I'm sorry.
you're fine. What were you going to say?
No, there was right angles at the top.
Yeah, this one's not a right angle. Up here.
That's what I thought.
But right angles do come into it. You've got that part right. You need to know, this is the 16 is the length of that related the rectangle. We need to know the width of that related rectangle. And the part of the triangle that tells us that width is the furthest point away. We have the side that's our base, length of our rectangle. There's only one, that base takes up 2 of the corners. There's only one corner left. Well, the distance from that far corner back to the base is called the height or the altitude of the triangle. That is altitude. I also suck at spelling, but that's okay.
That's like,
Altitude, that's the width of that related rectangle. So if I tell you that that dimension here is 13 feet, find the area of this triangle, it's going to be 16 feet, that's the length of the related rectangle, times 13 feet, that's the width of that related rectangle. And of course, divided by 2 because the triangle is half of the rectangle. Now you might be looking at this one saying, well, it's not so obvious that that triangle is half of the rectangle. But if we take it in 2 pieces, we look at this piece here, this triangle is half of that. We look at this piece over here, this part of the triangle is half of that. So the triangle is still definitely half of the related rectangle. That gives us an area of
good question.
Yes.
104 feet squared.
Perfect. Yes, sir.
You asked how much that was.
Okay.
That's a great question. I didn't do that in my head.
Now, like I said before, those calculations are all about patterns. You start to see the patterns, the calculations are pretty quick. You actually did one on this 168 up here. You did 2 times 4, or
Yeah,
2
I
times
did
7 and 4 times 7. Added them.
I just didn't have enough time for 16 times 13, so I'm like, yeah.
I cheated. I divided by the 2 first, so I did 8 times.
Hey, Todd, I'll be back real quick.
Okay. You're going to divide by 2 eventually anyway.
Yeah.
There are certain things in the order of operations that you can fudge, and that's one of them. Divide first instead of
So you took, what did you do with 13?
13 just stayed there. Just 16 divided by 2 is 8. So it's 8 times 13 instead of doing 16 times 13 divided by 2. I'm going to get to the same place either way. I just divided by the 2 first instead of waiting.
I didn't know that you could do that. I thought you had.
Like I said, strict order of operations says you got to multiply this first and then divide by 2. But there are certain places where you can fudge the order of operations. That's one of them.
I thought you would have had a divide 13 by 2 as well, but.
Nope, you just have to divide one of them when you're multiplying.
Oh.
Towards the end of this unit, we'll talk about factoring. That's what comes in there, is canceling out factors. What it is. Now, the triangle that's tricky to do, triangle looks like this. Yes, it's not a two's triangle. Let's say I know that this side down here is 20 inches. The related rectangle, actually, let's this.
Sorry about that.
Inside the related rectangle. How on earth can we get that triangle as part of that related rectangle?
Can't you just make 2 rectangles?
Well, what we do is we do make 2 rectangles. The first one, big rectangle, that does contain the whole thing. But you can see that triangle is less than half of that because it doesn't go all the way over here. But what we look at is this. I look at this right triangle is half of that big blue piece, right?
Well,
Green triangle is smaller than that. Then I look at this little rectangle that we just added onto the end of the brown one. This triangle is half of that. So if we did the geometric math there, the geometric addition or subtraction, green one does end up being half of the big brown one. So, or the half of the big brown rectangle. So we need to know the height of this related rectangle. Well, once again, we have to find that dimension on the triangle somewhere. And once again, it involves that vertex that is not part of the base. That corner over there that's not part of the base. These 2 corners are part of the base. It's the distance from that vertex to the base. But remember, distance is always measured perpendicular at a right angle. A right angle to the base is that direction. I can't come over and hit the base at a right angle. I have to go straight down, which means we have to extend that base over, make it a right angle. So it is this length here that we need to know. And let's say that that is 8 inches. Area of that rectangle then, or that rectangle, triangle, the green triangle, is area of the related rectangle, 20 inches by 8 inches, divided by 2 to give us that triangle. What do you think? Better than a sharp stick in the eye? So far?
so far.
Yeah. Sorry for disappearing multiple times. I'm the only healthy one in my house right now.
No problem. You guys know what a
Yeah.
trapezoid is? Trapezoid has 4 sides. And unlike a parallelogram that we had up here, both opposite sides were parallel. This side's parallel to this side, that side's parallel to that side. In a trapezoid, one pair of sides is parallel. This can look a couple different parts. The way we most commonly see it looks like this. And that top and bottom are parallel. The sides that are parallel are called bases. The base, this is a base. Notice I spelled one of them with a small b and the other one with a big B. Small base and the big base. Different sizes, of course. Distance between the bases, now distance is measured at right angles, so because they're parallel, I can get a right angle to both of them. That is the height. Let's put some dimensions on here. Let's say that the little base here is 12 inches. Let's say that the big base down here is 30 inches. And let's say that this height here is 15 inches. I want to find the area of this, just like the triangle relates to the rectangle. We have to do the same here. We have to turn this into a related rectangle. To do that, we're down our surface, halfway down, right there. Right down the slope. If I cut this right there, and cut it off square, this little piece here is the exact size to flip up and fill in there. So we squared off one end. We do the exact same thing on the other end. Go halfway down the slope, cut this down, flip up that little piece. Square it off the other end. That is now a rectangle. Now the height of that rectangle is still just the 15 inches of height. The length of the rectangle is somewhere between the two bases. Smaller than 30 inches, bigger than 12 inches. So how do I, what's that? Actually, it's not.
Boys, hush.
It's actually the average of them. I take the 30 inches plus the 12 inches, then divide by 2. It is the average of the bases. And then, of course, that's the length of the related rectangle. We still have to multiply by the width or the height. 15 inches. So 30 plus 12 is 42. Divided by 2 is 21. Times 15 is 115 square inches.
I was getting there.
I said, man, he's already got it in his head.
Not all parallelograms look like that, by the way. Not parallelogram, all trapezoid dishes.
I don't believe you.
This is a trapezoid.
That's a what?
That side and that side are parallel. The other two sides are not. Those two are.
I think that's a parallelogram.
Let's say that this side here is 6 inches. This one here we'll call it 12 inches. To find the distance between them, we have to extend these sides. This distance here, the height, let's call that 26 inches. So how would I find the area? What's the average of the bases? What are the two bases?
6 and 12.
12 inches, 12 inches by 2 to average them together, and then times what?
26.
6.
So 9 times 26.
Got it. 9 times 26, which is
234 inches square.
234 inches squared. Perfect.
Knew that one right at the top of the head.
You were reading it off while he was looking there.
Yeah.
I was actually trying to think. I got the 2. I'm like, okay. And then you said 34. I'm like, oh, I'm not there yet. Oh, he's got it up.
Let's look at a circle.
I don't like these.
If there's anything that we cannot relate to a rectangle, it would be a circle, right? Yeah.
Yeah.
First of all, a circle is defined by 2 parts: a center, then a distance from the center, which is called a radius. if I pick a point right here, right, that's my center. Then I pick a distance, so it's all points that are the same distance away from that center point. And that point's in the center. There's my circle. I'm drawing a circle. Not good for me. Radius is that distance. You remember how to find the distance around. It's called the circumference. But got the right idea. Let's look at this. The diameter all the way across the circle, right? Diameter is equal to 2 times the radius. Circumference, pi times the diameter, or times pi times the radius. You got it. Diameter is 2 times the radius. What's that? It's actually kind of neat here once you see how this fits together for the area. We've been told, of course, that the area is pi times radius squared. That's the formula you were given before, right? Yeah. Where does that formula come from? Well, if I take my circle, I'm going to cut it in half. Since all the way around the circle is 2 times pi times r, what would be the distance halfway around? Times pi times r divided by 2. Cancel out, that's pi times r, right? I'm going to take that half circle, and I'm going to cut it. Really thin pi wedges. Kind of like what we did with the squiggly thing. We cut it into really thin rectangles. This is cut into really thin pi wedges. Then I'm going to fan those pi wedges out. It's kind of like a sharp tooth comb looking thing, like, right? Now, if I take the other half circle and cut it into equally thin pi wedges,
I'm sorry.
fan out those pi wedges, stuff them in, they should exactly fit into the gaps of the first one. So what we have here, if we cut those thin enough, this is basically a rectangle. The length of this rectangle was the distance of halfway around, pi times r, right? What's this dimension? Radius. R times pi r is squared. That's the formula for area, or the area, where the formula for the area of a circle. You literally are turning the circle into a rectangle. I know. It's like, how the heck does a circle become a rectangle? Well, there it is.
Blasphemy. I'm kidding.
Witchcraft.
There you go. We have a circle with a radius of 4 feet. Area is going to be pi times 4 feet squared. I'm just going to write pi times 4 squared. 4 squared is 16. Now pi, you have a pi button on your calculator, 3.14152, or 1592, I should say. Memorize pi to like 10 digits?
I don't know, I just know.
I think I memorized it for one day until like 18 digits, and then I
5926.
Sure.
three,
You're
5.
You're out 7 digits, that's not bad.
Sorry,
Most textbooks just use 3.14 for pi as an approximation. When I do answer keys for tests or quizzes, I will use 3.14 and I'll use the pi key on the calculator. Any number between those two will be fine. So 4 squared is 16 times pi is 50.24. Okay. That's all about patterns, like I said.
I don't think I have enough time for the pattern to learn.
Let's say we have a circle here with a diameter of 10 inches. Area is going to be found by doing pi times
5 squared.
5 squared. Good. Where did the fuck come from?
Ah,
You got it. Radius has to be half the diameter. So pi times 5 squared, so 78.5, that's in inches, so the inches.
all right, I'll take your word for it.
I'm not going to argue. I want to know this.
I got
4 times 5 squared, 78.5. What's that?
Don't argue with him. He did it on a calculator.
You get a different answer, Sean?
yeah, I just got 78 even.
What happened there? Did you use 3.12 or something instead of 3.14?
Oh yeah, I messed up. My bad.
If you use the pi key,
Yeah.
you get 78.5398. Well, that's close enough.
You round down though, because the other one is not.
What did the sheet of paper say around that?
I would accept either answer. I would accept anything between 78.5 and 78.54 pretty much. So I'll accept either.
I typed in the right thing again, and I typed in your thing again. It worked this time. I kind of probably pressed the wrong button. Yeah, I have an app instead of a Texas Instrument because I'm in quarantine, so I have to adapt or something like that.
Well, I know you guys wanted something fun like this to do.
Oh God.
Alright, I got this, boys.
Right.
So look at this. First of all, there are some dimensions we need to find. This dimension across here. What is it?
Well, it's 13.
It's 12 plus 8.
It's 20. It's 20 because the
It's 5 from here to here, right? Across here would be the same as this. That'd be 12 minus 5, which is 7.
what I did was just add the 8 and the 12, and I just because it's 20, it's simple.
Yeah, that works too. So that 12 plus 8 is 20.
I don't know this equation off the top of my head.
It's just faster if you do it that way.
Because a lot of people don't see that that has to be the full 12 as it is down here. You look confused over there. You're not seeing where the 20 comes from?
Not seeing where the. I got
This
it.
is 12 here,
yeah.
right? So that means this has to be 12 right here. Since these are both 5, this has to be 12 across there. And add the 8 to give you the 20. Yeah. Now, the 12 and the 10 here would give us 22 inches here, right?
Wow.
Yes.
You gotta add the 4.
This is going to be 4 inches. You got it.
Talking about full
I didn't find the full height. Yes, the full height, 22 plus 4, which is,
26.
to find this, we have to break it into pieces that we know how to find. And that's going to be either rectangles or triangles, or trapezoids or circles. Here it's going to be all rectangles. I have 1, 2, 3 rectangles. That top rectangle is what sizes?
It's 4 times 20.
4 times 20
Equals
by inches
80
in
inches
there.
squared.
80 inches squared.
No, that's 80. Whoops.
Piece 2 is going to be how big?
7 times 12,
7 inches times 12 inches. You got it.
which is 84 inches squared.
4 inches squared. Piece 3,
10 inches times 12 inches, which is 120.
12 inches times 10 inches times 12 inches is 120 inches squared. We add that all up,
284 inches squared.
284 inches squared.
Are you monotone for like everything?
So we need to
Are you a robot?
cut it into those pieces that we can find. Now there's another strategy that is sometimes easier to do. We have a shape like this. Now I will tell you this. This is even across here.
Okay.
So if I tell you that this here is 6 inches, and let's go 15 inches, 5 inches, 5 inches.
It almost looks like a profile of a tractor engine I used to work on with my dad.
And we'll go 12 inches. So to find the area of this mess, I could cut it up into smaller rectangles, but it's kind of a mess. There's going to be a lot of them. Another way we can possibly do it is to make a big rectangle. That's going to be 16 by, what's the full length?
25.
25, you got it.
And then,
So 16 inches times 25 inches is 400. And subtract out the missing pieces. I've got a 3 by 12 here, which is
36.
So that's 364 after I subtract that out. Then I have to subtract the 6 by 15. 6 by 15 is 90, giving us 204 square inches of total area. So we could have cut that into small rectangles, and we would have had like 4 or 5 rectangles to do. Or we could find a big rectangle and cut out the missing piece. Final thing is to find volume. Volume, if I take that rectangle today, I pretend this is a rectangle. It looks like a parallelogram, but it's actually a rectangle. We're just looking at it from up above and off at an angle. Let's say this is 8 inches by 12 inches here. Okay. I took that length and I moved it in another direction to create an area. If I take this area and move it in another direction, slide it up, I create volume. Now, if you're struggling to draw that in your notes, if you're taking notes, you draw a rectangle, another rectangle the same size, connect. Right?
Used to be art student, would not have a problem with that.
So the height is 10 inches here, the distance we moved. So the volume, area of the base, the height. So the base of this is this bottom here, the 8 by 12. So the area of the base is 96 square inches. So the volume, area of the base times the height. So the 96 square inches times the height of 10 inches. 96 times 10 is 960 square inches times inches. Inches cubed. There's our volume. Okay, I've pretty much run us out of time, so page 17 through 19 in the book, 1 through 39 in the odds. Now here's where we start hitting the ones where you need to do more examples, do more of the homework, because there are going to be some problems in here that are kind of weird to try to chop up to find the area. So make sure you're going through some of those and finding the area of a pretty good number of them, and the volume of several of them. We are coming up. Just remember, next week we do have one more. We have the quiz this week that you got to remember to turn in. That quiz was from last Thursday, so make sure you get that turned in. There will be one more quiz this week, probably tomorrow, and then your unit test is going to be Thursday. So the way I handle it, since I'm working on Thursday, or since we're virtual, I will get the test posted on Blackboard. We'll log in Thursday, but at some point on Thursday, it's like for you guys, you can do a half hour before. You guys are virtual all day. So if you guys get the test done before class, you don't have to log in. I will be logged in case anybody has any questions. You can use your notes, your books, that are on the test. Obviously, I can't stop you since you're working at home. But if you have any questions, I will log in. If nobody logs into class in the first 10 minutes, I'll probably disappear and go on with my day.
When will the test be posted?
I'll have it posted by the end of the day Wednesday.
Okay.
As in, end of the day class period?
Well, probably right after class Wednesday. If I don't get it done
I
before
guess.
class Wednesday, I'll get it done right after.
I was just curious.
But yeah, it'll be posted. I'll try to have it posted before class Wednesday. Any other questions? Okay, well, it is that time, so guys, tomorrow.